Okay, so this is January 2021 paper. Question number one says this is very easy question. Relative charge of neutron is 0 and this is going to be plus 1. Relative mass of electron is 1 over 1840. Neutron is 1. Then number of electrons, it's gonna be 34 protons. There is no charge, so 34 electrons. And
Right.
number of neutrons means 76 minus 34. And for this one, I'm supposed to have selenium. It's 2 minus 34 and 36. Again, the same thing, 34. Because this is an isotope of selenium because the mass number is different. For an isotope, the mass number should be different. Okay, relative mass of this sample of selenium, relative abundance is also given. I can say it is supposed to be 1.2 multiplied by 76 plus 1.0 multiplied by 77, then plus 3.1 into 78 plus 10.8 into 80 divided by the total abundance multiplied by 100 divided by the total abundance. So the total abundance would be what?
Um, wait, I'll have to calculate 1.2 times 76 plus 1
16.1.
plus 27. I was doing the entire thing.
So 79. 79.1, yes. To one decimal place.
So, um, I'm not getting 71, 79.1. Like maybe I've made a mistake.
1.2 into 76 plus
1.2. Yeah.
into 76 plus 1 into 77, then 3.1 into 78, then 10.8 into 80. Are you not getting this one? What are you getting?
And then 16.1 and then times 100. Yeah, that
So you can, they are not saying percent,
7,950.
they are not saying percent relative abundance, so you can solve it without
Oh,
percent.
okay, okay. So
Then what are you getting?
79 point, then
If,
79.
yeah, I wrote 100. Okay. So it's 79.1. Got. Write an equation including state samples to show this ionization. The selenium atoms are ionized by electron impact through the mass spectrometer. So selenium gas is going to lose electron to form cation of selenium in gaseous form. Since okay, so describe how the selenium ions are accelerated, the time of flight mass spectrometer. If you remember, we used to, like, we have attached the negative plate in front of the ionic, like when the ions were traveling to the detector, to the detector. So I can say that negative plate is going to attract the ions. So I'm supposed to write uh, how the selenium ions are accelerated. So mm, I can say hollow disk having the negative charge attract which can accelerate positive ion through attraction. The same question. A different sample of selenium contains a fifth isotope. Okay. After acceleration, the selenium ion has a kinetic energy of this one. The ion takes this one, so travel this one. Calculate the mass in kilogram. Okay, 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 okay. So we have to calculate the mass and everything is given. Just we have to V, kinetic energy is also given. Time is given.
Sir, uh, can we? Or okay, never mind. Okay, okay.
Meter is also
Uh,
given.
yep.
So,
You have to find the mass, right? So,
yep. So
so m is equals to 2ke
it's
over
gonna be
v squared. Huh?
yeah, 2 ke over m is equal to v square. Then m is equal to 2 ke over v square. I know
Yep.
the value for Ka, that is going to be 4.742 raised to the power negative 14 divided by the v square, but I don't know the value for the v square, right? So what can I do for
But
the v square? I can
we know
say
the
that
formula of velocity.
distance over time.
Yep.
Uh, it's going to be 2.260 divided by the time, that is going to be 2.572 raised to the power negative 6. So what's the answer? In meter per second.
In meter. Okay, right. Um, I'll just solve it all together and get the final answer. So 2.260 divided by 2.572 times 10 to the power of negative 6. I'll square that. Um, so the final answer will be in 1.2 1.2 times 10 to the power of negative 25.
1.2, the final answer.
Yeah, it's coming out to be like this. The final answer.
10 to the power what?
Negative 25.
Okay. Kg, right?
Yeah.
Okay. Use your answer to question 1.6 to calculate the mass number of the ion. If you could not, yeah, we could. The Avogadro's, okay. Mass number. So I got the mass, that is 1.2 exponent 10 to the power negative 25 kg. I have to multiply this in grams as well, right? So then I have to multiply this with the Avogadro's number.
Okay. So mass number of the ion. So we found it in kg. So Why did you multiply by 1,000 to convert it into grams, and then grams to kg? Yeah, I mean grams to uh
Kilogram to gram
yeah, and then after that grams to
multiplied by
like
Avogadro's number.
okay, right. So it's like the mass number of time. Okay, all right.
Maximum mass. Okay. Nitric acid volume and concentration is given. So I can calculate the moles of zinc oxide, that is ZnO, uh, concentration into volume should be in decimeter cube divided by 1000. So what's the answer?
Um, 1.25 times 150 divided by 1,000 is 3 over 16 or 0.19. 0.19.
0.19 mole.
Yeah.
So it would be the same.
Yep. They're going to be the same. So now we just have to get the MR, which is 189.4. Yeah, it's given. So 0.19 times 189.4, 35.98, which is 36, basically 36 grams.
What's the answer?
36 grams.
Oh, okay. They gave us the nitric acid, not zinc oxide.
ZNO. Okay. No, HNO.
It's nitric acid.
Right.
That is 2:1.
So you'll divide it by 2. So 0.093. 17.6.
Yes. Okay. State how pure zinc nitrate can be obtained from the reaction mixture after the excess of zinc oxide is removed. And by the way, zinc nitrate is soluble. Zinc
Um,
nitrate is soluble.
State how pure zinc nitrate can be obtained. I think after the excess of zinc oxide is removed, so evaporation.
So we can do crystallization.
Okay, crystallization. Right.
Oh, again. Okay, PV is equal to nRT. Yeah. Volume should be in meter. Okay, they are asking the total volume. Okay, they have given the mass, and they have given the pressure, temperature, everything is given. Okay.
Yeah. Okay, so PV is equals to nRT. I'll use that, and I need to find the volume of gas. So I need to find both oxygen and nitrogen dioxide's volume.
Yes, total
Per
volume. So the
centimeter
total
cube.
volume means that the collective volume. It should be the mixture of NO2 and O2.
Right. So PV is equals to nRT, and 1 second. We'll leave the kilopascal and no, we'll convert the kilopascal into Pascal, right?
Kilopascal into Pascal. Yep.
So
First of all, we have to find out the mole of zinc nitrate. Okay.
yeah, and the temperature change, what would that be?
1.20
What
temperature
would
is to 200 degrees Celsius. It should be in Kelvin plus 273.
yeah, plus or plus, right? No, yeah, right, plus.
What's the answer?
Um, 1.2 divided by 189.4 is 6.3 times 10 to the power of negative 3.
Okay.
I
8.31
don't think so. You
into,
have to find out the um. You'll have
and
to do
then
the
we have to
okay,
take the mole ratio as well, right?
2
Before
to
applying the,
1,
yeah, 2 to 5.
2 to okay. You can do it directly.
2 to 5 is this one. We have to calculate the mole of, because here's in total volume. So I have to take the total mole ratio of the gases. So
What
X
I
would
was
be
thinking
equal
was to
to,
take I was thinking to take nitrogen dioxide alone and then oxygen alone, but okay, right. That would be a longer step. So 0.16, 0.016 is X.
0.16,
0.016. 0.
0.016.
Yeah, yeah, yeah.
Temperature 200 plus 273, 473. Divided by, yes.
Um. All right. Yeah. Okay. So, the answer is 6.2 9, 6.29 times 10 to the power of negative 4.
6.2. Okay.
6.3. 6.3
6.3.
times 10 to the power of negative 4.
Okay. Complete the equation for the reaction of, okay, balancing equation. They have given in AQA. Oh, okay. Hopefully it wouldn't be easy. That's why. It's not a simple.
Yeah.
So, okay, so I can say nitrate, nitrate. We have two nitrate. I can say two nitrate. By the way, after applying the rules, we can say balance the metals, then balance the non-metals, then balance oxygen, then balance hydrogen. These are the rules. So I'm looking at the zinc, 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 zinc is balanced. Then I'm looking at nitrogen. In the product side, I have one or three nitrogen atom. So I can say three
1 second,
nitrogen. I'm
sir.
supposed to write no four nitrogen. Yeah,
The rules for balancing is metal.
balance metals, then balance the non-metals, then balance oxygen, then balance hydrogen.
Okay, metals, non-metals, oxygen, hydrogen. Okay.
So four threes are 12 oxygen. We have three twos are six oxygen, then three oxygen, then one. So it should be 6 plus 3, 10 oxygen. We have to have 12 oxygen atoms, right? So what if I write 6 plus 3, 9 plus 3, 12? What if I write 3 over there? So oxygen is balanced.
Yeah.
3 plus 3, yeah, oxygen is balanced. Then hydrogens. 3 to it has right now I have 4. Right now I have 4. So let's say if I would be writing 6 and then 4 and then 6 plus 4 is 10.
Wait, what are you
So
balancing right
it's
now? Hydrogen.
hydrogen, yep, because oxygen is balanced.
Okay.
So I need to have 10 hydrogen atoms. Oxygen was already balanced. So I'm going to write 10 over there. Hydrogen is balanced, right?
Now what?
Hydrogen is balanced, right?
Yeah.
Now I need to do oxygen again because oxygen is imbalanced. So it's understood that it would be 3. 3 plus 3. 3 plus 3. Like we have 10 oxygens in the product side. 3 plus 3 plus 6. No, 12 oxygens. Am I right?
Yeah, 12.
12. So how many oxygens I have right now? 30. Oh, so how can I make it 30?
30 is
Let's
not
say,
divisible by 12, but you can do 5 over 2, I guess.
no, 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 no,
2.55
no.
over 2.
Basically, if I cannot write any number over there, so it should be 3 and it should be 3. 6. So I need 24 more oxygen atoms. So what if I would be writing 4 over there? 4 into 2 is
Oh,
8.
yeah.
8 into 3 is 24, isn't it? So this is balanced.
Oh, yeah.
And after writing
Right.
4, the zinc is 4. So I'm supposed to write 4.
Right.
That's why they have given. So we can apply the rules. Otherwise, it would be very toxic. It would
Right.
take a lot of
Okay.
time. It's hit and trial method.
Hmm.
Then, why molten magnesium oxide conducts electricity? By the way, magnesium oxide is an ionic compound. And they're asking to, oh, okay, we have to complete it. So, oppositely charged ions, opposite, then opposite, then opposite, then opposite, then opposite, then opposite.
Free electrons is the answer of the next one. Free or mobile electrons.
No, free ions, not electrons.
Is it because it's
Whenever the examiner
oh,
would be asking about the conductivity of the metal, then you are supposed to
mhm.
write free electron. But this is not a metal. It's an ionic compound. So for an ionic compound, ions are present. Remember, for an ionic
uh,
compound, ions are present, isn't it? So we have to say free ions.
yeah.
Yes.
So when do you say free electrons again?
It would be wrong for a metal. For a metallic bond, for a metal, copper, sodium, lithium, potassium, chromium, zinc, iron, cobalt, nickel. So why the metals are good conductor? Because they have free electrons.
Okay.
There's
Are we
no
done with that past paper?
possibility. Yes, no, lot of remaining.
Yeah. Wait, so transitional metals have free electrons, right?
All metals, not transition, all metals.
Then which ones have the free ions? Ionic metals.
Ionic compounds.
Okay. And the example was magnesium oxide.
Yeah, it's an ionic compound. It's a combination of metal and
Right.
non-metal.
I can't see your screen, by the way.
Okay. Yes. Name and explain the shape of the nitrogen trichloride. Suggest the value of the bond angle.
Nitrogen trichloride. So nitrogen and three chlorides. 1 second. Uh, Nitrogen is 2, 5, and chloride is 1. So it will have, I think, one bond pair. I mean, one lone pair of electrons. Nitrogen,
Nitrogen has one lone pair, yes.
one lone pair. So, and three bond pairs. One lone pair and three bond pairs.
Yes.
So, 1 second. Okay, wait, no, never mind, right. Right, okay, so one lone pair and three bond pairs, that would be, I think, the angle would be 109.5,
No, 107 degrees.
107, right. And the name of shape would be, is it the pyramidal thing?
Pyramidal shape, yes.
Pyramidal, right.
And explanation?
It has three bond pairs and one lone pair.
Yep.
Is there supposed to be
Some
more to the explanation because it's 4 marks, right?
Yeah, exactly. So we can say that because there is a repulsion between the bond pair and lone pair. So the compound is more stable when there would be less repulsion. Okay. So there is a repulsion between the lone pair and bond pair. The
Okay.
repulsion between the lone pair and bond pair is greater than the repulsion between the bond pair and bond pair.
Okay.
This repulsion is greater.
Okay. So lone pair repels more than bond pairs. Okay.
So that's why the bond angle is 90°.
107, you mean?
Sorry, in 107 degrees, right? Yes.
Okay.
Okay. Why the boiling point of CHF3F is much higher than that of fluorine? It's understood.
CH3F has hydrogen bonding, so its intermolecular forces of attraction are stronger than that of F2, whereas F2 has uh, temporary dipole forces. I think
Yeah, you can
The
say.
Van der Waal forces.
Good. Because, fluorine has only van der Waal forces like this one. It has only van der Waal force is weaker, right?
Yeah.
On the other hand, it's supposed to have permanent dipole, which is stronger.
Permanent dipole is the same thing as Is it the same thing as hydrogen bonding? No, right?
Hydrogen bonding is specific to the non-metals, to the elements, but it's not specific. Yeah, kind of, you can say it's the same thing. But whenever the permanent dipole would be between hydrogen and highly electronegative elements, so I can say that this would be hydrogen bonding.
So right now it is not hydrogen bonding.
Yes.
So what's the difference between what is permanent dipole? Like
It's
how
the
do I
force of
know?
attraction between the polar molecules. It's the force of attraction between the polar molecules.
And hydrogen bonding is between hydrogen and NOF, right?
Yeah, exactly. Phone. Yep.
So there is also like carbon here. So is that the reason that it's not hydrogen bonding or something? Because there's
Uh,
carbon?
yeah, you can say it's carbon. Yes, it's like that.
So no, is it not hydrogen bonding because of carbon?
Yep.
Okay. So it's the permanent dipole and temporary dipole is basically van der Waal forces or dispersion London, whatever you can call them, right?
Yes.
Okay. So the permanent dipole forces are between non-polar elements.
No, temporary dipole.
So permanent ones are between polar.
Polar. Yes.
Okay. One second. And polar elements are with the higher difference in electronegativity, right?
Yep. Yes.
All right, done. Okay, we can move on.
Draw the structure of AlCl3.
Yeah.
It's trigonal planar. You know why? Because three bond pairs and zero lone pair. That's why.
Right. Okay.
Okay, so they're asking the dative covalent. Okay, it would be like that. It's a covalent, and yes, I can say no, 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 like that, isn't it? And even
Right.
we have to draw in this manner, like a trigonal planar manner. So I can draw like that. So
Okay.
trigonal planar, it's a trigonal planar. Same structure. So
What is wrong with what you drew earlier?
I'm considering the geometry as well. It was trigonal planar, right? In
Right.
the previous question, we said that it's a trigonal planar. So it can be
Okay.
like that. Okay. So 2 marks.
All right.
Okay.